All right, you also asked to see number 13. So again, we'll take the derivative to do part A. F prime of x, derivative of sine is cosine, derivative of cosine is negative sine, and we want to set this equal to 0 to figure out the critical numbers. So what we get here is, I'm going to move the sine over to that side, so we get cosine x equals sine x. And there are different ways you could solve this. Probably what I would do, though, is think about the graph. Because they're only asking about from 0 to 2 pi. Cosine x looks like this, and sine x looks like this. They cross in two places. One of them is right here at pi over 4. The other one, they cross here, which by symmetry, and my graph kind of sucks here, but by symmetry, that's going to be at, I think it's 5 pi over 4. I'm actually doing this outside right now, and I don't have anything but my iPad with me. I'm going to draw this again. Let's see. So sine looks like this. Cosine looks like, let's see, it starts up here. Yeah, so that's going to be right here. That's at, because this is pi, this is 5 pi over 4. You could also do that with Desmos and see where they cross pretty easily there. All right. So let's draw my number line and cut it up. My iPad is frozen on me. All right, let's try that one more time. So I'm going to draw the number line. And actually, I don't need the whole thing because they just said go from 0 to 2 pi. So we'll go from 0 up to 2 pi. And we're going to cut it at pi over 4 and at 5 pi over 4. And then I want to evaluate f prime of x in between. So let's pick some numbers. Pi over 4, I'm going to use pi over 8 here. Let's see, in the middle, I'm going to use 2 pi over 4. Actually, no, I'm just going to use pi here for my middle number. And then, because that's, 4 pi over 4. And then over here, between 5 pi over 4 and 2 pi, let's use 3 pi over 2. Let's make sure that's in the middle. That would be the same as 6 pi over 4. So it's definitely on this side over here of 5 pi over 4. All right, so let's plug some numbers in. Or let's plug these in. If we do f prime of pi over 8, I get cosine of pi over 8 minus sine pi over 8. And I'm going to just stick that into my calculator. I'm actually pulling out my iPhone here. Let's see. See, cosine of pi over 8 is 0.92 something minus the sine of the same thing. Okay, that's positive. And I just got that by evaluating this on my calculator. All right, for pi, I can do that one because I know cosine of pi minus sine of pi. Cosine of pi is -1, Sine of pi is 0. So this is -1. And then 3 pi over 2. Let's see. Sine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is 0. So this is +1, so this is plus. So we're increasing here, decreasing here, increasing there. So let's see. I'm not going to write these down just for the sake of time, but we would, actually I will. I'm not going to be lazy here. It's increasing on 0 to pi over 4 and 5 pi over 4 to 2 pi, and it's decreasing on pi over 4 to 5 pi over 4. All right, let's see. Just from looking at the curve here, we've got a max there and a min there. So we have a local min of something at x is 5 pi over 4, and a local max of something else at x equals pi over 4. And if we wanted to come up with the values that go in here, we would just plug 5 pi over 4 and pi over 4 back into the original function. All right, and to do the concavity, we would basically do all of this stuff again, except instead of using f prime, we would use f double prime. And f double prime would tell us the concavity.